All right, so we'll be solving rational expressions in this video. And what we want to start off by doing first is restricting our domain. So what values can and not use? So this one, if our denominator goes to 0, this term will be undefined. So we're going to say that 2x plus 3 cannot equal 0. And then we're going to solve. So I'm going to subtract 3 from both sides. So 2x cannot equal negative 3. And then I'm going to divide both sides by 2. So x cannot equal negative 3/2. Okay, same process for this second one. And on the second one, what we're going to be looking at is x minus 4. So I've got an x minus 4. That cannot equal 0. And when I look at that one, I'm going to add 4 to both sides. So x cannot be 4. So in our solutions, if we were to keep working this one through, what we would want to acknowledge is the fact that if we generate a 4, or if we generate a negative 3/2, we would not be able to use them in our answers. Okay? So for the second one, we have to solve the equation of 4x plus 1 over x minus 2. Whoops. X minus 2 plus 2 over x equals negative 4 over x squared minus 2x. Okay? So looking at this, we have to restrict our domain first. So for this one, I'm going to take my denominator and say u cannot equal 0. So add 2 to both sides. So my denominator cannot, my solution set cannot include 2. On this one, x cannot equal 0, and it's already solved. And this one should look familiar to you because it's just the factor or the multiplied out form of x times x minus 2, which is these two denominators that we just had. Okay, so if I factor this, x times x minus 2, I get this one times this one, which is what we're going to do at this point in time, is I am going to multiply and get a common denominator through this thing. Okay, so this one needs an x, so I'm going to multiply top and bottom by x, and this one needs an x minus 2, so I'm going to multiply top and bottom by x minus 2. This one already has the x, and it already has the x minus 2. So that gives me, moving down to here, a 4x plus 1 times x plus a 2 times x minus 2 equals a negative 4 over x times x minus 2, x times x minus 2, x times x minus 2. Okay, so looking at this, what I've got is my numerators are now all going to be set equal to one another. So I'm sorry, I said that wrong. I'm going to distribute this one, so I get a 4x squared plus an x plus a 2x minus a 4 equals negative 4. And all of that is over x times x minus 2, x times x minus 2. So we're going to combine this one. So I've got a 4x squared plus a 3x minus a 4 equals negative 4. And then I'm going to add my 4. So my denominators are still there. I'm just kind of ignoring them right now. Okay. So this gives me a 4x squared plus 3x equals 0. So I'm ignoring them because I've already decided what they can't be. So I've got my common denominator. So looking at this now, I can factor out an x. And that gives me a 4x plus 3 equals 0. So either x can be 0 or 4x plus 3 can be 0. So I would subtract 3 and divide by 4. So x would be negative 4/3. So we need to come back up and look at our restricted domain. I'm not allowed to use 0, and I generated a 0. So this is called an extraneous solution. It means I did my math right, but for some reason I'm not allowed to use my answer. So 0 cannot be used, so we've got a single answer of negative 4/3. So we've got 6y over y minus 5 minus 30 over y plus 5 equals 300 over y squared minus 25. So we want to restrict our domain first. So y minus 5 cannot equal 0. So y cannot be 5. Y plus 5 cannot equal 0. So y can't be negative 5. And then your final denominator is a y plus 5. Y minus 5 cannot equal 0, which is the product of these two. Okay? So I'm going to go through. Now that I've restricted my domain cannot include a 5 or negative 5. So my solution set, if I determine that one of my solutions is a 5, I can't use it. If I determine that one of my solutions is a negative 5, I cannot use it. So looking at this, I'm going to get my common denominator. So, in fact, let's do a different strategy on this one. And let's multiply through by y minus 5, y plus 5. So I'm going to multiply through by y minus 5, y plus 5, and that might make a little bit more sense to you as to why we don't have to use the denominators. Okay, so if I multiply this first chunk by y minus 5, my y minus 5s will reduce, and I'll be left with 6y, y plus 5. This one, my y plus 5's reduce, so that leaves me with minus 30 times y minus 5. And on this one, my y plus 5 and y minus 5 reduces, so that leaves me with minus 300. And so now I've cleared the equation of the fractions, and that's why I didn't have to use fractions, the denominators in the last one. As soon as you have restricted your domain or restricted your solution set, you can just go ahead and clear your equation of fractions and get rid of them. Okay, so now we're going to distribute. So I've got a 6y squared plus a 30y minus a 30y plus 150 is 300. So I distributed my 6y and got a 6y squared plus 30y minus 30y plus 150 equals 300. So this gives me 6y squared plus 150 equals 300. So I'm going to subtract 300 from both sides and get a 6y squared minus 150 equals 0. And I'm going to factor out a 6. So that leaves me with y squared minus 25 is 0. Divide both sides by 6, so y squared is 25. And now I can factor. So I get a y plus 5, y minus 5 equals 0. So y plus 5 can equal 0, and y minus 5 can equal 0. And hopefully you're seeing where this is going right now. The only two solutions I found are the two that I'm not allowed to use. So I found that y can be -5, but I'm not allowed to use -5. And I found out that y can be +5, but I'm not allowed to use +5. So that means that my solution is the empty set. There's nothing that's going to make this thing work. So my solution is the empty set.